Good evening, students. Welcome to our video on linear inequalities. Music tonight brought to you by Regina Spektor. Took me a while to decide which selection to play, but I really like her. So if you want to know more, you can do your own research. Okay, let's jump in with some definitions. A linear inequality in two variables is formed when we replace the equal sign in a linear equation with an inequality symbol. And you know your inequality symbols. You know them as let's see, let me get the right writing utensil here. You know your inequality symbols as less than, greater than, less than or equal to, and greater than or equal to. So remember that when we graphed an inequality, when we were looking at single variable inequalities, it was a line with a circle that was either open or closed, and then shading that went one direction or the other. And then usually you could shade in the arrow too. Well, the difference here is that our inequality graphs are going to be made up of a line that's either broken or solid with shading on one side, and we'll actually get into that in just a minute with an example. But the solution of an inequality that has two variables is an ordered pair that makes that inequality true. So that means that when we have our graph, we'll have our either broken or solid line and then shading on one side. Okay, and the solutions are the points that are in the shaded section right here, or on that line if it's a solid line. Let's try a couple examples. Before we do any graphing, let's actually go ahead and test out a couple of ordered pairs. So what I'm saying is, determine if each of these ordered pairs here, these three, determine if they're solutions of this inequality. We're going to do that by plugging in the numbers. So if y is 6, 6 is less than or equal to 2/3 times the x value 3, plus 4. We're going to get 6 is less than or equal to 2 plus 4, or 6 is less than or equal to 6. Well, 6 is equal to 6, so that's true. True. So yes, that point is on the graph, or in the graph, included in the solution set of that inequality. And in fact, it's actually, we can tell here that it's on the line because 6 equals 6. So it's not in the shaded part, it's on the actual line. All right, 0, 0. 0 is less than or equal to 2/3 of 0 plus 4. 0 is less than or equal to 0 plus 4. Yes, it's true. So yes, that is also in the graph, but that's in the shaded region because 0 is less than 4. Last ordered pair, 4 for y, and -3 for x. 3's are going to cancel there, so -2 plus 4. And we get 4 is less than or equal to 2, which it indeed is not. So that is false. And this ordered pair is not on that line, or in that graph, or a part of that solution set. Great, let's do a graph. So it's really difficult to get this to graph nicely, so you're going to have to bear with me. I'm making the lines as straight as I can. That's like the straightest I've made it yet. That's not too bad. Okay, so we're going to graph this like we learned before, because we're going to graph the related line, y equals 1/2 x minus 1. We're going to graph that by graphing the y-intercept of -1, and then using a slope of 1/2, rise of 1, run of 2, up 1 over 2, up 1 over 2, up 1 over 2, and so on, all the way down. All right, so we graph the related line, but don't draw the line yet, because we got to think about this. Greater than. That means that the points that are on this line are not part of the solution set. Because like we had when we had just single variable inequalities, a greater than is like an open circle. That's your broken line for your two variable inequalities. So to make this a broken line, just kind of connect the points like that. And now we're going to determine which way we shade. Now you can think in terms of y is greater than, and you shade up, which works really well when your line is closer to horizontal than vertical. But the best way to determine which way to shade is to take the origin right here and plug it into the inequality. If you get a true statement, so let's see, 1/2 times 0 is 0, minus 1, 0 is greater than -1, that's true. If you get a true statement, you know that 0, 0 is on the shaded side. And that means this is the side that's shaded. Now you can you know, shade with the side of your pencil. You can just draw lines like this, as long as you indicate which side is shaded. Okay, let's try another. Alright, get a different color. Interesting, you get different... I'm trying this a different way this time. The appearance is different from what I'm used to, and you seem to get more color choices when you do it this way. I'll put in my X and Y axes, or Y and X axes, in the order that I drew them. Okay, we're going to graph again. We're going to graph the related line Y equals negative 3x plus 4. So plot the y-intercept of 4, and a slope of negative 3 over 1, or 3 over negative 1. So negative 3 and over 1. Negative 3, positive 1. Negative 3, positive 1. Negative 3, positive 1. And all the way down. And all the way up the other way. This time a solid line. Ooh, I missed a little bit there. Let's see. Can I go back? Back? Oh, no, can't. Okay, so pretend it's actually on the line. Woo! Uh-oh. Now I'm really messing up. Hold on. Okay. Pretend it is actually on the line. Okay. Test out 0, 0. Alright, 0 is greater than or equal to negative 3 times 0 plus 4. So 0 is greater than or equal to 4. That is false. So, if that's false, then 0, 0 is not in my solution set. It's got to be the other side. And that's the side that we shade. And that's how we graph a linear inequality in 2 variables. What if we have one with 1 variable? Remember, those are horizontal and vertical lines. Alright, so let's start by putting in our x and y axes. So we're going to be, this time we're going to graph y is greater than negative 5 and x is less than or equal to 3. So I'm putting in my x and y axes. Don't have to make them perfect, obviously. I can't because I'm kind of wobbly here. Alright, what's the related line here? If y is greater than negative 5, the related line is y equals negative 5. So recall, please, what we know about horizontal and vertical lines. Thanks to Mrs. Rankin, we have our acronym. So a horizontal line has a 0 slope, is a y equals equation. So y equals negative 5 is horizontal at negative 5. But I'm going to make it broken. Why are we making it broken? Because it's y is greater than negative 5. And which side would give me values greater than negative 5? Shading above. And this one's different. We have x is less than or equal to 3. So again, hoi vux. Vertical line, undefined slope, x equals equation. Alright, so x equals 3. Where does x equal 3? Here, and this time it's solid because it's less than or equal to 3. And where do you look on your graph to find values of x that are less than or equal to 3? Well, you look to the left. We can't say up or down because it's a vertical line, so it's either left or right, and less than would be left. All right, one more problem. And yes, it's a word problem. I'm not sorry, no. All right, let's read. A student with 2 summer jobs earns $10 per hour at a cafe and $8 per hour at a market. The student would like to earn at least $800 each month. Write and graph an inequality to describe the situation. So we need an x and we need a y, and we need to define them. And we're going to be using x and y as hours, number of hours the student works at each of the 2 different jobs. So let's make x the number of hours at the cafe. And let's make y the number of hours at the market. Well, $10 times x hours is the amount of money that he or she will earn at the cafe. How do I express the amount that he or she will earn at the market? 8y, very good. And we want that to be at least $800. So go back. Gosh, it's been a while since we've done this. At least. Can it be equal to 800? Yes. But at least really means more. And there you go. There's the inequality. We wrote it. Now we need to graph it. So in order to graph that, we're going to need to solve it for y. So let's do that on this page before we go to the next page where the actual graph is. So I'm going to subtract 10x from each side. And think about how you're going to write that. 8y is greater than or equal to negative 10x plus 800. Divide by 8, divide by 8, divide by 8. And we have y is greater than or equal to negative 5/4 when we simplify x plus 100. And that is what we will be graphing. Okay. When you graph a consumer application like this, we know we're only dealing with the first quadrant. So I'm going to put my x-axis down nice and low, my y-axis way far over to the left here. So we got 0 at the origin, and every 2 lines is going to be 10. So there's 50, 60, 70, 80, 90, 100 hours. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So again, let's see, 1, 2, 3, 4, there's 50, and there's 100. And we need to know that this is hours at the cafe, and over here this is hours at the market. And we're graphing y is greater than or equal to negative 5/4 x plus 100. So y-intercept, 100, and there it is right up there. Now, here's something that we can learn that will help us a lot graphing something like this. I counted basically by 5s, but really by 10s is how we labeled it. I can't use down 5/4 because I can't count by 1s here. Sorry guys, bit of an editing jump. So anyway, I can't count down 5/4, so this is what we're going to do instead. What we're going to do is we're going to count down 50 and over 40. It's the same ratio, but it fits our numbering system. So, down 50 over 40 would put us right here. Down 50 over 40 would put us right here. And that's the line for our inequality. All right, normally we would just shade down because it's a negative slope and it's, greater than, so it's actually shade up, shade up. So, da-da-da-da-da-da-da-da-da-da. All right. Okay, so the question that we now have to address is actually on the next slide. So I'll make a copy of this one and make an extra slide. So let's go. If the student can work no more than 90 hours per month, how should she split that between the market and the cafe? Probably have another bit of an editing jump, I apologize. So she can work up to 90 hours per, I think that said week, it really should have said per month. So 90 hours per month. And how should she split that? Well, that requires us to think about yet another inequality. X plus y, the total number of hours she works, can be no more than 90. Okay, and what would that look like? Well, that would have a y-intercept of 90 and a slope of -1. So it would go down like so. And what's cool about this, I missed by 1 there. You see that? I messed that up a little bit. I'll have to fix that in a moment. Okay, so that gives me this line. Please ignore the other 2 blue dots. And it's shaded down. Well, and where do the 2 overlap? They overlap where they cross, which is right here. 50-40, or 40-50 is the ordered pair. 40-50. So that means 40 hours at the cafe, 50 hours at the market. Awesome. So I know I had a little editing trouble there at the end, and I'm not writing out my sentence like I'm supposed to with a word problem, but I think I did better with the music than I did on previous ones. You can let me know how I did in class. We better quit because it's probably getting long. So, hope you enjoyed linear inequalities. I'll see you guys in class.